All right, so we're here to talk about Harvey Diversion, 65% design for the fish passage improvement project. And maybe just a little reminder of why we're here. Under existing conditions, Santa Paula Creek has a degraded stream profile downstream of the Harvey Diversion structure. It does have a previously constructed fish ladder and an extension to the fish ladder, but the fish ladder is now inoperative, so it's a complete barrier for fish passage. But the upstream watershed on Santa Paula and Cesar hold habitat for spawning and rearing. And the graphic at the bottom there is just a 2-mile snapshot of the profile of Santa Paula Creek, and Harvey Diversion shows up as this drop-in profile, which is about 30 feet of drop-in profile and forms the barrier for fish passage. And then just a little bit about how we got here. In planning and design work funded by CDFW, an alternative known as HD3 was selected, which restored the profile of Santa Paula Creek to provide passage for fish in the stream. It's about a 5,600 foot long reach, and it also lowered the crest of the diversion structure. So basically raised the profile downstream of the diversion and lowered the profile slightly upstream of the diversion structure. There were grade controls on stream profile, and an infiltration source, an infiltration gallery was proposed for the diversion to improve fish passage. So that's kind of where we started with the alternative we're pursuing. And then on this project, NHC and our partners have done a feasibility assessment. And one of the main findings there was that the infiltration source was not really reliable as the sole source of water. So it caused us to look at surface diversion again. We identified some data needs for establishing the design profile, made some suggestions about the grade control structure design, and we developed a preliminary surface diversion concept. And then the next phase, 30% design, we did some data collection, geologic and geophysical data collection, some survey work. We used that to establish a design profile, which includes about an 8-foot lowering of the diversion structure at the lowest point. And we laid out a surface diversion, which required a pump station to be able to pump into the existing diversion pipeline. We did retain the infiltration concept, but as a secondary source, or maybe you could consider it a little bit experimental, but retained as a secondary source. And we produced preliminary plans and a design report at that stage. And since the 30%, one of the things that we've been doing is looking at that diversion pipeline. At the end of the 30%, we really weren't sure about the condition of the pipeline and its capacity to carry the diversion over a long lifetime. So we did a condition assessment, including some CCTV work and a geotechnical assessment of the slopes. And basically what we found is that the pipeline is pretty irregular in cross section. It has some areas where the CCTV couldn't go, or we couldn't see anything because of water in the pipeline, but there's also a lot of accumulated sediment in the pipeline. And at the same time, we were kind of looking at the condition of the pipeline. We did some hydraulics, just thinking about whether it would be possible to eliminate the pump station on the diversion and continue to go by gravity, even though we are lowering the crest of the diversion structure by 8 feet. So that required looking at some of the facilities downstream to see where we could tie in with a gravity line. Excuse me. And then the end result was that a new pipeline has been proposed, a new gravity pipeline proposed for the surface diversion instead of the pump station on the surface diversion. But because the infiltration source is even lower, the infiltration source is below the stream bed, and so it's even lower than the diversion crest, that will still require pumping, and so we're proposing a package pump station for that. that source. We also did a sediment assessment. Ventura County and City of Santa Paula were interested in the potential effects of the project on sediment delivery downstream for flood control performance. And so we did a sediment assessment, and basically what that showed is that in the major events, when the largest quantity of bed material is being transported, that the project would not increase or would have a slight decrease in sediment loads. We did see a slight increase in the more frequent events, the 2-year events, but the overall sediment transport in the stream is dominated by, especially the large bed material, is dominated by the big events. So overall, we don't expect an increase in sediment loads downstream. And then the grade control structures are quite challenging actually to estimate their effects in the stream because of the large bed material and the high slope. So we did an independent scour assessment, trying to hone in on scour expectations at the grade control structures, and that gave us some numbers to go forward with geotechnical and structural design. And at the same time, we looked at in the scoured condition after a big flood event, how will fish passage work, and that caused us to make a few modifications to the grade control design. The stream design, I won't read all these words, but just some of the things that we have been working on. The typical sections were modified to be a little bit wider. The grade control structures were modified, as I said, based on the scour assessment. The diversion structure crest design was tuned up for flow control and fish passage. We added a section of upstream bank protection and grade control structures. We had sort of forecasted that might be needed in the 30%, but now we have a layout for that. We updated the sizing for the engineered stream bed material, the stream bed material that's going to be used in construction for both the grade control structures and the stream in general. And then we updated fish passage performance at the grade control structures and flood performance for the project. And I won't try to go through all the plans. That would take us a long time, I think, but this just gives a general idea of what we're doing in the stream. So this is a profile of the stream, and it's showing the existing ground is kind of faint here. Hopefully people can see that, but it's showing that in order to restore the profile downstream of the diversion, which is this location here, you're basically filling the existing stream bed, and then in the top layer, we're constructing that as a stream channel with stream bed material, and the grade control structures are here to provide stability after construction for that stream channel. On the upstream side, it's sort of reversed. We're lowering the stream profile, so we have cut on the upstream side, but it's in general quite a bit less than the fill on the downstream side. So I won't go through all the profile sheets, but that's in general what we're up to. The typical sections were modified a little bit to be wider, and also to let the thalweg location vary in location in the stream, give us a little bit more hydraulic diversity in the stream. And as I mentioned, the grade control structures were modified. So this is kind of a general schematic of the layout of grade control structures. They're spaced at about 200 feet apart. So this structure with the little wings and this structure with little wings are grade control structures, spaced 200 feet apart. And we have modified these slightly, but we've also added a roughened channel section between the grade control structures. Helps us to control tailwater in the scoured condition on the grade control structure, so that we add some resistance in the stream, and we control tailwater so that even after scouring, if we develop a pool on the downstream side of the grade control structures, fish won't have to cross a vertical barrier to pass through the grade control structure. We have two types, and I won't go into the details here, but the two types of grade control structures. One uses piles to reinforce the structure. The velocities on Santa Paula Creek are very high, and there's very large bed material moving. The flow per unit foot is one of the highest I've seen, actually. And so it's not really possible to stabilize these structures with just rock. And so we've used, in this case, piles to help reinforce it. And in the second case, concrete to help reinforce it. The concrete version is generally used towards the downstream end of the project where the fill depths are lower, and it's easier to put a gravity or mass structure in there. And for every grade control structure, there's a rock key that fits on the bank to try to prevent flanking around the grade control structure. I mentioned the upstream bank protection, and so this is the diversion structure crest right here. This is the intake, which we'll talk about in a couple of minutes. And this is the section that's upstream of the diversion section. So this area here is existing bank protection. The highway runs right along here, and we're going to be lowering the stream profile here. If we lower the diversion crest, we'll also be lowering the stream profile. And so there's concern about lowering it to the extent that it would destabilize the protection for the highway. And so we've laid out basically a vegetated bench to provide a buffer, a vegetated buffer between the existing grouted rock protection for the highway and the stream channel. And that vegetated bench would be stabilized with buried rock groins. So in a really large event, if we lose some of this vegetation, or perhaps we lose the bench material, these groins will still be there to hold the stream platform. The pipeline, you can just, it's too small maybe to see here, but the pipeline, see if I can get there, sorry. Very slow. One moment. The pipeline leaves the intake area and runs downstream along the stream channel. And the pipeline will be lower than the existing pipeline and towards the stream channel. And so we will need some protection for the pipeline for the first about 300 feet of the pipeline going downstream. Further downstream, it moves away from the stream channel. So we have some buffer between the stream channel and it connects to the existing pipeline about 900 feet downstream of the diversion structure. I mentioned fish passage design and the updating. So we've, based on the changes in the design, we have updated our fish passage hydraulics at the grade control structures and at the diversion. So these are just some graphics showing the velocity distribution across the grade control structures at the juvenile high fish passage design flow, and at 50% of the Q2, which is the adult high fish passage design flow. And in general, velocities are 2.5 or low for a pretty good portion of this channel, and 6 or below for most of this channel. We have looked at the Q2, the peak flow, peak Q2 flow, or 2-year flow as well, trying to get fish passage up that high. And in general, velocities in the channel are going to get in the 8 to 10 foot range, so exceeding our target of 6, but the margins are still in the 6 range. And these velocities are generally the same as we're seeing in the stream, upstream, and downstream of the grade control structure. So they're really not very different than the stream in general. It's just a pretty high velocity stream. We also updated our flood comparison, and so these are velocity plots from the 2D res model for the Q10 or the 10-year flow. and existing on the left and the proposed on the right. Because we are increasing the stream gradient with that filled profile, we see higher velocities in the proposed condition than in the existing, but a pretty similar pattern in terms of inundation. I mean, a little bit more width in the proposed condition because of the fill. And in the 100-year condition, existing again on the left and proposed on the right, again some higher velocities in the 100-year. But probably the thing that catches our attention most here is that we have some overbank flow up on the terrace in the agricultural area at the 100-year condition. So that's something that we'll be looking at in the as we go forward in the next phase. For the surface diversion design, it is a passive intake, meaning that we don't have a dam anymore. So it really relies on stage control in the channel at the diversion structure. There's a gated intake structure to be able to shut it down when flows are too high. And we have laid out a concept with vertical screens that would be sized to meet NIMS and CDFW screening criteria, tapered screen bay that would sweep fish past the screens to a fish bypass and back out to the stream channel. And because we're operating with a range of stream stages, we need to operate through a range of stages as flows change in the creek. We have a range of about 4 feet, and in order to do that, we have adjustable weir gates on the backside of the diversion and on the fish bypass for flow control. And we've talked about the gravity pipeline. The infiltration collectors are upstream of the diversion structure and covered with armoring rock so that they will be protected, and they flow to a package pump station to lift that flow into the same diversion pipeline going downstream to the Bridge Road Reservoir. And this is how the diversion structure looks. So the layout of the diversion structure. So this is the diversion structure crest here. The infiltration collectors in the stream bed, the intake for the diversion, an approach channel leading to a screen bay. So it's a screen bay right here. Fish bypass with a pipe leading back out to the stream to bypass fish, into an outlet pipe, and then into the diversion pipeline, which heads on downstream. So that's the surface diversion flow path, and then the infiltration flow path comes into the collectors, goes into this line, and goes into a sump. And this is the location of the package pump station. Gets lifted up through a valve vault and back out into the outlet box and down the same pipeline. And there is a head tank here, which would be also filled by the pump station. That provides head so that we can occasionally backflush these infiltration collectors to clear them. In terms of operations, the surface diversion is sized for an 8 CFS capacity. The first 2 CFS in the non-adult steelhead migration season, or the first 5 CFS in the adult migration season, is bypassed in the stream. It doesn't enter the intake structure. And then above that, we start to make diversions. And the switch between those 2 modes would be made with weir operations and flashboards in the intake. And it gives us the capability to divert. We start diverting at 1 CFS when we have 3.5 CFS of stream flow in the non-migration season, or 1 CFS when we have 6.7 CFS in the migration season. And we get up to the capacity of 8 at about 17 CFS in the stream, or 22 CFS in the stream. So that differs a little bit from the way the existing diversion works, with a kind of this passive style of diversion and control. And so we have calculated, based on the flow duration characteristics in the creek, we calculated the potential yield for Canyon, so that they can look at their water yield and ensure that the operation is going to meet their needs. And that's included in the design report. And this is just a quick picture of kind of how it looks. So on this side, we're looking basically straight downstream over the diversion structure crest, and water is being diverted into the intake and into the approach channel, and then through the screens and into the diversion, which is controlled by this outlet weir. And the bottom line is a 1 CFS profile, and the top line is an 8 CFS profile, both at low stream flow. So this is kind of the range when stream flows are low, controlled with the weir. When stream flows get higher, we operate all the way up to about 623.5, or about 4 feet of height difference. And in order to do that, we push this outlet weir up to control the diversion flows. Now the infiltration diversion, also 8 CFS capacity, 2 12-inch by 40-foot collection screens, and as we said, it goes to a package pump station and lifts the flow into the diversion outlet. The control for that system would be in the pump sump level controller, and we'll also have to have stage control at the diversion structure to make sure we can pass our 2 CFS or our 5 CFS before we start making diversions. And if you're wondering what the heck a package pump station is, it's basically a big vault underground. So ground level would be at this level, and a hatch to access the pumps in the vault, the risers coming up one wall with the ability to lift the pumps out on rails. And that discharges to a valve vault, and then in our case out to the discharge outlet box and into the diversion pipeline. We have some things in progress. I just received the structural design today for the diversion, the intake area. We have a lot of elevation difference between the highway and the stream. And so there are some big walls associated with the intake in order to provide vehicle access to the intake area. So we have 4 walls kind of as you go across from highway to stream. And so we've just received the structural design for that. We will be updating the quantities and cost estimate from the 30% based on the changes we've made. And we are working on a draft O&M manual for the diversion. And so just some key things moving forward from our perspective. The flood protection level, we're making a pretty big change in flood water surface elevation. So the landowners or property owners are going to be very interested in that. And we have some work to do for landowner acceptance and hopefully cooperation on that front. We have quite a few things to tackle on construction implementation, access and staging, control of water, and some of those will also require some coordination with the property owners. Because of the concept, the HD3 concept, we're filling the channel downstream and we're cutting the channel upstream. There's a fair amount of impact, or maybe there's a large amount of impact to existing vegetation. It will be temporary. We can salvage some of that vegetation and reuse, and the project would include planting, but it's a fairly large area of vegetation impact. And the operations are going to be key, to protection of steelhead. So getting an O&M manual draft out for review will be important for that. And then something that we said in the 30% design is that the stream stability, the grade control structures, we're dealing with a very high energy stream, and some form of adaptive management is going to be required to ensure that the project performs and provides fish passage over the long term. So there needs to be an institutional framework for that adaptive management to occur.
And I know I'm new, but how far upstream of the Santa Paula Creek Channel is the end of this project? Is it a couple thousand feet or a couple hundred feet?
I think it's about 2 miles, Aaron.
2 miles. So I noticed that, at the 100-year, water gets out of the channel up into the terrace area.
Yeah.
So I'm just anticipating that, one of the questions, the Corps with the big C might have is how this project could affect the downstream existing, levee system and channel.
Yeah. Yeah.
I'm sure Antal might have brought that up as well. But,
Yeah.
regulatory, we can't issue a permit that's going to interfere with the function or congressionally authorized function of an existing core structure. And so, I think in addition to what you have here as a key topic, showing that the downstream existing flood control structure will still function adequately or, meet its congressionally authorized purpose, should probably be another key topic moving forward.
Okay.
Just because it's, in our regulations as a, the regulatory component of the Corps of Engineers is that we couldn't issue a permit that's going to interfere with that downstream structure.
Aaron, this is Dan Tormey from Catalyst doing the permitting. And in our part of this, we do speak to the analysis of the change in the 100-year floodplain, the Clomer analysis. And I believe that would also address the potential impact to downstream flood control structures. Is that your understanding also, or would that be a separate analysis?
It's certainly linked. The Clomar is going to be FEMA. And so they may loop our core engineering division into that. And also, of course, Ventura County Watershed Protection District also would be involved because they have maintenance responsibility over the Santa Paula Creek channel. And they would definitely be involved in the Clomar as well.
Right. Okay, good. That was our understanding, that we'd be starting with the county and then move outward from there. Yeah. Okay. Okay. So, once Ed has described very well the design and how we've moved from the 30 to 65% and the details in that. And so in the environmental part of today's presentation, I was going to first sort of translate the engineering design into project description speak for the CEQA and NEPA permitting and identifying, or CEQA and NEPA analysis, as well as the permitting requirements. And that'll be the focus. And then at the end, since we will be, as Russell mentioned, reaching out to you as the time comes for the different permits, we'll be reaching out to you specifically. And if there's any feedback on preferred ways that we can communicate with you, we'd like to hear that as well. So this slide shows the project area that Ed was talking about, and the major features, these grade control structures downstream of where the diversion is going to be removed. We've got Mud Creek over here, in which there'll be fill as well, and then on upstream. And then in addition, we've got the different staging areas that have been identified, for supporting the construction, as well as the different access roads. So this map in a nutshell shows you the different parts of this system that would have some disturbance, and either some permit or component of the analysis of CEQA and NEPA would look at that. Let's see, Ed covered this quite well. Yeah, it's a nice picture though of the complete barrier there and the existing pipeline. We're looking at Mud Creek here. And then, overall, we're seeking to restore passage up into identified but not currently used critical habitat in Santa Paula Creek. And, this has been a goal for many years. And, now that Russell and CalTrout have really taken this on, we've now proceeded further than I think anyone has before. You know, we've got this nice 65% design, and we have a good, I think, a good idea of how to get our required environmental approvals. And then Canyon Irrigation is able to maintain their water supply needs and rights as well. And so those are the objectives of the project, and good progress is being made towards those. You've seen this drawing in Ed's presentation, but this I thought was a good one to show the permit area more. Let's see, we don't have a Ventura County representative on with us now, but if they do watch this by video, we had spoken with the county earlier about the need for a grading permit, and specifically whether that permit would involve a CEQA requirement or not. And at that time, it was this area away from the boundaries of waters of the state and waters of the US that would answer that question of whether the county has a CEQA trigger or not. And so stay tuned. We'll be reaching out to them to determine this question. Let's see. I don't think there's anything more that Ed didn't cover on here that that I want to bring up. Okay, and so now this shows, again, we've got Santa Paula Creek running here, Mud Creek up here, and now we've sort of zoomed in from that broader scale picture we'd looked at 2 slides ago to the area of the existing diversion, and this is where most of the work is going to be occurring, again, from a permitting perspective. And so this shows, you know, we're definitely within that area, working within the stream, where we'll need a lake and stream bed alteration agreement from CDFW, a dredge and fill 404 permit from the Corps, and a 401 water quality certification from the regional board. Other elements outside the stream, especially any riparian, you know, Ed had mentioned needing to look more at the need for veg removal as part of this. That would be covered within the lake and stream bed. Let's see here. Okay, yeah, those are the main things I wanted to cover here. And again, what our team is doing is taking that 65% engineering design package that Ed and Gwen had put together, and to try to bring it into the, you know, this air photo base that shows us in environmental terms what aspects might be affected. Okay, and now a subject of a lot of work over the past 2 to 3 years has been addressing the issue of construction impacts and operational impacts. And in particular, Aaron, this is where Antal has been particularly active in helping us define precisely what the Corps' 404 permit will address, which is construction-related effects, and that as far as longer-term operational effects, potential for long-term channel scour or erosion, the operation and maintenance plan that Ed had mentioned, periodic monitoring to determine whether any repairs are needed to any of the facilities. Those kinds of long-term impacts we had understood would not be addressed in the 404, and that had led to discussion with NIMS about whether a Section 7 consultation with NIMS or a Section 10 would be the most appropriate. We've put forth several ideas, but where we landed was that a Section 10 would be required. So Aaron, I'll have a couple of questions for you as I move forward about that, but this is the core question of it. The core, C-O-R-E, question of it is the construction versus operation. Okay, so this is the federal side of the house for the permits and approvals. I'd mentioned the Section 10 with a habitat conservation plan, with really a focus on the long-term operation and maintenance impacts. The 404 permit, as we were looking at this and working with Antal, the nationwide 27 is appropriate for this. And then we talked a little bit about the Clomer and looking at the effects, both, the Clomer, Aaron, as you had clarified, starts from a FEMA base, but then works outwards to look at the downstream effects as well. Okay, so that part is fairly well known at this point. Where we've got some questions has to do with both NEPA and specifically bringing in the long-term operational piece of this, which would be in the Section 10 consultation. And so, Aaron, since you're here and NIMS is not, I'll be asking you, your opinion on whether the NEPA coverage provided by the nationwide Permit 27 could meet the requirements of the Section 10 ESA NEPA. Not for you, but if NIMS is watching, another question we have is whether the CEQA component that will be on the next slide, there is a memorandum of understanding between the state and the federal Council on Environmental Quality that is what's known as a CEQA Plus document, a CEQA document that does also address federal requirements, could be used for NEPA compliance for this longer term operational piece in the event that Aaron tells us that the nationwide 27 coverage would not. That would be our next question for NIMS, if you're watching. All right.
So
while we're here,
27 is only gonna, the NEPA document is only gonna discuss construction impacts.
Okay.
So, the work in waters of the United States. And so my preliminary answer is that NIMS would probably have to do their own EA to cover the long-term operation and maintenance of the structure, or at least an EA. I guess it's their determination as the lead agency, but I don't think nationwide Permit 27 is gonna be adequate to cover that longer-term focus of the the HCP, the Section 10 permit.
Okay, thank you for that.
What was the second question?
Let's see.
Oh, 106.
Yeah.
So, the Corps is required to do Section 106 as part of our permit action. Once again, we're going to be focusing on the construction impacts. And, in discussions with NIMS, they could decide that, what we do for 106 and tribal coordination is adequate. Or if they feel just, throwing it out there, let's say as part of your long-term operation maintenance and involve construction activities in uplands that are going to be outside of the scope of our 106, they could decide, hey, we've got a broader scope that we need to cover because of this, long-term maintenance and operation. And then we could decide to let NIMS be the lead for 106 as part of them doing their Section 10 permit. And then we would utilize their 106 consultation to satisfy our federal requirements.
Okay.
So I guess the answer to you is, depending on which of us has the broader scope, only one of us necessarily has to do 106 and the other could utilize the 106 that the lead agency does. Is that clear?
Yes.
Yes.
This is Megan. I work with Dan. On the topic of environmental assessment and one for construction and one for operation, since it's an overall project, has there ever been history of NIMS and Corps working together as lead agencies for a single environmental assessment that covers the entire project in both sets of jurisdiction?
we're actually working on a joint EIS right now for the Freeman Diversion, where NIMS is the lead and we're a cooperating agency. So usually, you have one lead agency and then you have a cooperating agency. And it is feasible to do that for EAs, but usually federal agencies prefer just to do their own EA, just because doing a joint EA is very cumbersome, given the size and scope of the document. You're looking at 50 or 60 pages. But it is possible. I don't remember ever doing a joint EA with NIMS or another federal agency. What I have done is the Corps has written an environmental assessment, and then I've had the Forest Service take our EA and then use it to support their federal decision on Forest Service land. And I think what they usually do is use a lot of our environmental analysis, put it into their format, and then do their own EA, but we've done most of the work for them.
And I had a related question, and that is that, as where the discussion has progressed so far is that NIMS's basis for wanting to do section 10 and a habitat conservation plan is for the longer term operation and maintenance elements, but that still does leave the construction related impacts. And it seems odd to do section 7 for construction with the Corps as the federal lead agency seeking advice from NIMS, with their opinion from NIMS. And then for the second half of the project, NIMS doing their own section 10. Do you see any paradoxes with that?
Well, what we've normally done, and this has been with the Fish and Wildlife Service, the most common example is when the Fish and Wildlife Service does an HCP for a given area. And so take is already authorized and there's terms and conditions. It's a form of a section 10 permit. In those cases, what the Corps does is we have to consult, but we usually do an informal consultation. And basically in our letter, it says there's a section 10 permit for this project or area. The take is already authorized and the terms and conditions have already been set. And the permittee is agreed that they're going to incorporate all the terms and conditions from the 10A permit. And so we've just done an informal consultation, and then hopefully NIMS would just send a concurrence letter back agreeing that there is an existing section 10 permit, the take and the conservation measures are all established, and the Corps has met their requirements to consult under the Endangered Species Act. So I agree with you. It would be silly to do a biological opinion for the construction impacts and a section 10 permit for the operation and maintenance. I would expect that NIMS would do a 10 for the construction and the operation and maintenance. And then the Corps would just do informal consultation, basically saying that, the permit's going to comply with that existing section 10 permit. Okay,
good. Yeah, I was thinking there had to be something like that. And so that really clarifies it. Thank you, Aaron. Yeah.
Sure.
All right. Let's see. So now we're moving to the state and local. Let's see. So I'd mentioned on our maps the need for the lake and stream bed alteration agreement. We also have California Endangered Species Act consultation requirements. And Christian, sorry, I didn't mean to miss Fish and Wildlife Service consultation either. It's just that the work that has led to the current regulatory pathway was primarily through NIMS. So apologies for that. Yeah, okay, so we have the California ESA as well. I'd mentioned the 401 certification. There'll be a construction general NPDS as well, and the Ventura County permit. And then with respect to CEQA, I mentioned when we were looking at the maps that we had spoken with Ventura County a few months ago related to whether their grading permit would include a CEQA analysis. And at that time, it depended on the footprint of the out of channel construction. So now that we have that with the 65% design package, Ventura, if you're watching, we're going to be calling you and asking your opinion on that. We've also talked with LB Nye at the LA board and had tentatively heard from her that if Ventura County is not the CEQA lead agency, that is their grading permit turns out to be ministerial as opposed to discretionary, that the next state approval up would be the 401 certification, and that CEQA would be through the board. Valerie, I know that you're with us representing the regional board. I'm not sure if LB's talked to you about that at all. Yeah.
Hi, LB didn't mention that to me specifically, but this has always been the case where if what other entity out there isn't taking the lead, we generally don't prefer to be the lead, but if we have to, we're able to do that. So because this is another layer of where Fish and Wildlife, California with Fish and Wildlife isn't taking the lead like where they generally would in most cases for our projects, we have the ability to do so. So and it would be me taking over and taking care of that part. So we can.
Great. Okay, good. And we are doing all we can to have the local, that is the county, be the lead agency. That, that is common for them, that, as land use
Right.
and land management agencies. And so that is definitely our plan A. But again, we had narrowed it down to whether or not the footprint of the out of channel construction would bring in a discretionary action by the county. And
Right. And
So-
I understand that. So if you, for some reason, get into a situation where it's just not happening or it can't happen fast enough, or you need that extra help, then we're there to take that lead.
Awesome. Great. Thank you, Valerie.
You're welcome.
Okay.
Hi, Dan, this is Barron with CDFW. A couple questions. Have you looked into the SB 155 that was passed earlier this year for restoration projects?
We have, and I'm going to turn that over to Megan because she's the half of the we that was looking at that very closely.
So Baron, the way I understand that Senate bill statutory exemption is that your restoration project couldn't include any construction that was not specifically focused on restoration. And so because the project also includes the construction of the diversion for Canyon Irrigation to continue their diversions, I had assumed that we wouldn't qualify in this case. But I would be more than happy to get your expert advice on that if you thought that it was something that could apply.
Well, if it's funding a diversion, I think you're right. I don't think SB 155 would apply. So yeah, I can look into that a little bit more just to confirm. Yeah.
Aaron, Christian and I, and Christian Romberger, the grant manager here, also dual role is kind of leading the new permitting, kind of the outreach for those in the region here. Me and him talked about that quite a bit. Still would be very interested to you circle back with them and have that conversation again. But yeah, the existence and the upgrading of the diversion facility, he thought it would be a pretty tough hurdle to prove that was restoration focused.
Mm-hmm. Okay, and then just to kind of piggyback on the discussion that you guys were having before, if the county can't serve as CEQA lead, CDFW generally takes the same approach that the water boards do. We prefer to have another agency be the lead, but we can be, particularly if Steelhead's listing and you have an LSA that you need to acquire for the project, you know, then we may end up being the de facto lead agency if the county isn't able to. And just another thing I wanted to clarify, and Christian may have clarified this already with you guys, but there's 2 LSAs that would likely be required for this. So there would be the first LSA for the construction, and then the second LSA would be the operations of the facility post construction. Again, I'm new to the project, so Christian may have already told you this, but I thought I'd point it out in case.
Is the reason for separating those out timing so that we get the streambed alteration agreement in order to do the construction, and then we could work on the streambed alteration agreement for operation after?
Well, I mean,
any-
that's part of it, like logistically, but also they're going to have different types of requirements as far as, you know, what type of measures we'd want to see in the agreement. So construction, and you're pouring asphalt or whatever it is, or concrete, you know, that's a different kind of project scenario where we'd want to have different type of protection measures rather than, you know, working with fish screens and, you know, clean outs and stuff like that. That makes sense?
Yes, it does.
Okay.
And since I still, Dan hasn't started saying anything yet, we had initially considered that an initial study mitigated neg deck would suffice for state permitting, whether it was the water board, the county, or CDFW, that the other agencies would be able to use that for their purposes as well. Is that your understanding as well?
I mean, based on what I'm seeing so far, I think so.
Okay.
Okay, great. Thank you, guys. That's very helpful for this. These are, I mean, as far as our hopes for the meeting, both the last discussion with Aaron and this discussion with Valerie and Baron have really helped cleared up areas that still had a little bit of gray for us. And so especially on the CEQA, we still are kind of in that gray zone, and that we need to work directly with the county to see if they would be the appropriate lead agency. But it's nice to know the pathway towards a plan B in the event that they are not. Okay, and then this provides just our overall view of the schedule. At this point, we've got the last month completing the 65% design. Surveys, delineations coming up later in this year, spring and summer. And then we're looking towards like August, September of 2022 to be ready to submit permit applications. And then CEQA would take roughly, if we do the initial study, negative deck or mitigated negative deck route, approximately 6 months after that. And so permits, once the CEQA is certified, then the state permits can be issued. And then let's see, so the 404, so the section 10, we did have that discussion about the dependency, and we're pending discussion with NIMS. We believe that the section 10 is going to be addressing the full project, both construction and operation, and therefore as part of, or as far as the Corps' timing, it would depend on that section 10 timing, because, you know, Aaron, as you know, you'd need that completed before you could complete your permitting and the NEPA. So yeah, so that's our overall timeline. So headed into late 2023 is when we're anticipating being completed with these steps. Okay. Any questions on that one? So this is just, you know, for planning purposes, we always know that it's there's queues and it's tough, sometimes tough to get in them, and so we're trying to give some advance notice. All right, and so this so this is the, how do you like to be communicated with kind of way. And, a meeting such as this, which I would kind of call this a workshop, where there's information exchanged and open discussion, and then it leads to us moving forward based on the discussion. I personally like the workshop format because everybody can hear what everybody else has to say and work from there. So that's option one. And then the other is to just have, more using email or other format like that, a little more impersonal updates as we go. Is there, put you all on the spot, I guess I could call on everybody, but does anyone have a preference for this? Do these workshops work for you, or do you prefer more one-on-one and a bit more remote, like emails? Yeah.
This is Valerie from Waterboard. I'll just say for myself, it really helps to have these meetings with everyone at the table because it's a little more efficient, and just let us know when you'd like to choreograph the next meeting. And it's really helpful for me to see the diagrams and be able to ask questions on the spot. And like today, hearing Aaron be able to make a comment about a particular thing that we're looking at right there on the spot, it's really helpful. So that's just my input, but anyone else can chime in.
Great. And I saw Aaron do a thumbs up as well. So we've got 3-4. I'm including myself as a vote. I really agree with you, Valerie, that to me, this is like the most efficient way to spend an hour and a half as you could, to push emails around. Can seem quick, but overall it takes longer, and you miss the group dynamics as well. Yeah. Okay, if there's any
I
other.
was gonna say, you catch my attention. I'm so busy and I have 500 emails a day to look at. And, when we have a meeting like this, it's really letting me sit and focus on what you're showing me and, how can I help, or what do we need to question, and super helpful.
Yeah, and the drawings and the figures, to us, they tell such a great story and are almost self-explanatory, but they're not, and so to have it talked about, I think that alone makes these things so valuable. Yeah. Okay, any other thoughts on that? If you have strong thoughts either way, you can email Russell, but sounds like we have sort of a groundswell that group meetings as needed, when we have real material to work through as we did today, that we'll probably keep with that. And I had said it earlier, but this has been really great for Megan and I to get a much clearer view of the pathway. So thank you all for that.
Yeah, thank you, Dan. That was great. And I think that's, unless anyone has any other questions or comments they think they want to make, I think that the discussion during that permitting planning section was pretty good. And as Dan said, you get to see just kind of the equal exchange of ideas and thoughts on the project, and just, really cements that we're all in this working together to remediate like historically, prioritized stream passage barrier removal, our project in the Santa Clara Basin. So appreciate everyone's time. And
hey, this is Steve from CDFW. Sorry, I was multitasking, but I heard Barron speak up about the LSAs. So one difference between the construction and the operations and maintenance agreements are your operation and maintenance agreement is going to be covering the activities you would need to do to operate your facility, your diversion, over the life of the diversion. So, we have limits to how long we can write them. You might want to get a long-term one or whatever, but your activities of routine maintenance and the operation of the diversion, you're going to want to LSA for beyond the construction. So that's why there's two different ones.
Yeah, that's a good point. That operations and maintenance one would definitely be a long-term agreement. That would be the preferred path. Yeah. Thank you.
Sure.
Steve, is there any way for that document to very much mirror the HCP, because that's that's kind of what that is going to be required for, as well as long-term maintenance operation of the facility, or if there's any kind of joint effort that those two link up, or is it totally separate?
That's a good question. I mean, yeah, a lot of the science that's used to create the HCP will be used to write our LSA.
Okay, yeah. I mean, it's same with that. What hopefully will be the requirement for an ITP for Southern Steelhead at the state level as well. So.
Yeah, regarding the ITP, that's different. That's a different subject, and we have a requirement for for the impacts to be fully mitigated, which is a little different than the federal side. So we're not sure which projects fit into something with a consistency determination, or would need a separate ITP. But we're going to figure that out, as it comes along.
Yeah, we're turning some new water here.
Yeah.
So we appreciate your help, and yeah, any kind of, if you see anything on the horizon with that or have any thoughts, we're open to those discussions as well. At least I am, and we think that's pretty important also. So appreciate that.
Yeah, sure.
Yeah, and Steve, as we're in the section 10, we'll work to keep you and Baron engaged in that, at least with updates of where we are, so that if, for example, the differing levels of mitigation come up, that might be a time you might want to engage. So we'll just try to keep you apprised as we go along. Yeah.
Great. Absolutely. Thanks. Invite us to any meetings. We're happy to join.
Thank you for that.
Russ, just to piggyback on what Steve said. So we are responsible for the protection of all fish, so our LSA language could be, it's going to cover steelhead, but it's also going to cover some of the other native fish that you wouldn't really address in the your HCP. So yeah.
Okay, that's a good point. Thank you. Yeah, that's, I get myopic at times, but I should revert back to being a stream ecologist at heart.
That's always a good place to go back to. So.
Awesome. Well, that's I appreciate everyone's time today. That was a great meeting. Hopefully, have some more of these, going forward, where we really begin to, tear into all these questions we have and get towards some, concrete ending to get this thing in the ground and restore a pretty critical stream in the Santa Clara River Basin. So appreciate everyone's time. It's getting near the weekend here. So have a good weekend, and we'll be talking to you soon.